For nearly 40 years, Voyager 2 gave us our only close-up view of Uranus. We thought we knew its moons, but something was hiding. Now, the James Webb Space Telescope has seen what Voyager could not. A faint point of light, just 10 kilometers across, revealing itself as a new moon. This tiny object may be shaping the planet's entire ring system. It's a discovery that proves even the smallest moons can hold the biggest secrets. What if Uranus has been hiding a moon so small and faint that Voyager 2 never saw it? This is science in progress, and the finding has not yet completed peer review. On February 2nd, 2025, Webb's near-infrared camera, or NIRCam, captured 10 long-exposure images over 6 hours that revealed a 10-kilometer-wide object. NASA announced the result on August 19, 2025, with the provisional designation S2025U1. Its orbit lies between the known moons Ophelia and Bianca, raising the question, is it simply a stable moonlet, or could it be shaping Uranus's rings? To explore that, let's look back at the moment Webb saw what Voyager could not. The moment Webb saw something Voyager couldn't. How could a moon roughly 10 kilometers across have gone unspotted for nearly 40 years? Astronomers confronted that question after Webb recorded a faint point of light orbiting Uranus in 2025. To see why it remained invisible for so long, we need to look back to Voyager 2's flyby in 1986. That mission provided the first close-up images of Uranus, its rings, and its moons, revealing 10 small satellites inside the ring system. But Voyager's visible light cameras had strict limits. They could only register bright objects within a narrow dynamic range, leaving dim, low reflectivity moons below the threshold. In other words, if S2025U1 was there then, Voyager simply could not detect it. Here's what changed. Voyager relied on visible light, while Webb's near-infrared camera, NIRCam, captures faint infrared signals with exceptional sensitivity and higher resolution. This combination allows astronomers to separate out dim signatures that would otherwise be lost in Uranus's glare. With that advantage, Webb succeeded where Voyager could not. Detecting such a small and faint source marked a significant leap in our observing power. Once brightness was measured, astronomers estimated the moon's size by applying a common assumption: albedo, or surface reflectivity, how much light the object reflects. A higher albedo means a smaller body can appear brighter, while a low albedo body of the same brightness must be larger. Assuming values similar to Uranus's other small satellites, researchers calculated a diameter of about 10 kilometers. If the surface reflectivity differs, that number could shift, but this baseline provides the best current estimate. Webb's observation occurred during a planned imaging sequence on February 2nd, 2025. Over about 6 hours, the telescope captured 10 40-minute long exposure frames using NIRCam, part of program ID 6379. By comparing those frames, astronomers saw one faint point shift consistently relative to the background stars, moving with Uranus itself. That repeating motion confirmed the source was not a distant star, but an orbiting body. The consensus view is that Webb detected a genuine inner moon of Uranus, though continued monitoring will test and refine this conclusion. Per standard practice, the International Astronomical Union assigned it the provisional label S2025U1. That designation remains in place until follow-up observations confirm its orbit and a formal name is chosen. This is a reminder that planetary science is a living process. Discoveries begin as working findings, subject to review, confirmation, and eventual incorporation into the accepted map of the solar system. The contrast between Voyager's limitations and Webb's capabilities highlights how each generation of instruments extends our reach. Faint moons that once went unnoticed can now be tracked across multiple exposures. That shift reveals not only a single object, but a broader pattern. Every time technology advances, new members of planetary systems appear. The Uranian system, in particular, still holds secrets despite decades of study. For astronomers, The finding underscores how much remains to be uncovered in this remote corner of the solar system. The Moon itself is small, but its position and orbit carry significance. To understand what role such an object might play, we need to see how it fits within an already crowded neighborhood of moons and rings surrounding Uranus. A crowded neighborhood. Around Uranus, where does a moon only 10 kilometers across belong when orbiting among nearly 30 companions? To answer that, astronomers point to Uranus's innermost region, a place where rings and moons are tightly arranged and often overlap in influence. Unlike the sprawling satellite systems of Jupiter or Saturn, Uranus's inner zone is compact, with bodies following close tracks around the planet. These small moons are modest in size, but occupy orbits where their gravity interacts constantly with neighboring objects. It is here, in this compressed setting, that S2025U1 has been identified. Current measurements place the new moon about 35,000 miles, 56,000 kilometers, from Uranus's center. That distance lies within the cluster of small satellites known as the inner moons, specifically between Ophelia on the inside and Bianca on the outside. With this addition, Uranus now has 14 known inner moons and 29 overall. The expanding count shows that what we know about the planet's system changes each time telescopes reach deeper into faint light levels. The real challenge for scientists is to understand how so many objects remain in orbit without destabilizing one another. Each moon must hold its path while at the same time adjusting to the pulls of Uranus and the perturbations of close neighbors. This balance makes the Uranian system unusually dense compared with other planets. Adding even a moon the size of a small town introduces another factor into an intricate gravitational arrangement. Why care about an object so small? Because in this crowded region, size does not dictate influence. Even minor moons have gravity strong enough to affect ring particles. By moving through a band of dust and ice, a body can sharpen an edge, create wave-like features, or open a subtle gap. For Uranus, where rings are thin and dark, these interactions are crucial to their persistence. Astronomers consider each moon not as a passive bystander, but as an active part of a system shaped by constant small forces. Webb's data suggest that S2025U1 moves in a nearly circular orbit. A circular orbit means the moon is not being strongly pulled into elongated or unstable motion. In practical terms, this points to long-term stability, supporting the hypothesis that the moon has occupied roughly the same track for a significant period. As weeks and months of follow-up measurements accumulate, astronomers will be able to test this by confirming that the moon continues to trace a predictable path without noticeable perturbation. What emerges is a picture of structural balance. Every moon, however faint, contributes to the layout of the inner system. Seen in this way, S2025U1 is not only an addition to Uranus's census, but a working piece of its architecture. The statistics, 14 inner moons, 29 total, provide the context, yet the deeper story is how each member interacts over time. This makes the new object not just another catalogue entry, but a functional part of Uranus's orbital machinery. The question that now follows is more specific. Beyond simply fitting into the system's structure, what role might S2025U1 play in shaping its immediate surroundings? Could a body this modest still have a measurable effect on the rings that encircle Uranus? Stable moonlet or ring shepherd? The consensus view is that S2025U1 is a stable moonlet. This means it maintains a relatively fixed orbit inside Uranus's inner system. Its nearly circular path, measured from Webb's imaging sequence, supports the idea that it has been in this location for a long time. A stable orbit points to a passive role, where the moon exists in balance with its environment, rather than disrupting it. At this stage, most astronomers consider this explanation the most likely. A working hypothesis is that S2025U1 could be acting as a shepherd moon. In planetary science, a shepherd moon uses its gravity to confine and shape a ring, keeping particles from spreading outward or collapsing inward. The best analogy is a sheepdog nudging a flock back into place. In this case, the gravitational pulls are slight but steady. If S2025U1 happens to orbit close enough to the edge of one of Uranus's rings, its influence could be enough to maintain that edge with surprising effectiveness. At Saturn, moons like Pandora and Prometheus serve this exact role. Uranus already provides an example too. Cordelia, about 40 kilometers across, helps hold the Epsilon ring's inner edge in place. That precedent shows how a small body can take on an outsized structural role in shaping rings. The shepherd moon hypothesis is not proven yet, but it remains a serious possibility that guides how astronomers approach the new data. Another hypothesis is that S2025U1 is a collisional fragment. The inner region of Uranus is crowded, and over millions of years impacts likely shattered and reformed many bodies. Some pieces disperse, but others settle into orbits that remain stable. A fragment caught in this way may slowly be recognized as a moon in its own right. If confirmed, this would suggest the object's history is more violent, tracing back to a breakup event between earlier moons. Its current shape and composition could supply clues about those past collisions. For now, this idea is still untested. More information about its reflectivity and possible changes in orbit are needed to evaluate the history that best explains it. If the orbit continues to prove circular and stable, then the discovery means more than adding one name to a list. It requires revising the numerical models that describe Uranus's rings. Current simulations already include the influence of shepherd moons to explain how ring edges remain sharp. Adding another moon alters the balance of forces in those models. Updating simulations in turn changes predictions about how long Uranus's rings survive, how often small collisions occur, and how minor fragments may appear or vanish over time. Even though S/2025U1 is only about 10 kilometers wide, its confirmed presence would ripple through this wider framework. Beyond theory, there are practical consequences for exploration. Every newly identified moon becomes part of the catalogue that planners use when designing spacecraft trajectories. The more accurate the orbits, the lower the uncertainty for future flybys or orbiters. Small moons do not present insurmountable dangers, but uncertainties in their positions add caution to planning. By mapping them precisely and confirming whether orbits remain circular or drift slightly, mission designers can chart paths that reduce risk and maximize the scientific return. In that sense, building this catalogue is an essential step before any new spacecraft arrives at Uranus. Seen in perspective, discoveries like this form a steady progression. Voyager 2 offered the first map of Uranus's neighborhood in 1986. Decades later, Webb revealed what Voyager could not. Each generation of instruments exposes structures and companions previously hidden in the planet's glare. Each discovery, no matter how small, resets our expectations of what may still lie unseen. S2025 U1 illustrates how finding a moon the size of a town can shape both scientific models and future mission designs. The next observations will determine its long-term status, but the discovery already shows how even subtle details deepen our knowledge. From cataloguing moons to refining models, each piece contributes to a clearer picture of how planetary systems truly work. And while the process is still underway, it reminds us that progress in astronomy often begins with faint signals that later redefine the larger system. This sets the stage for a final thought. Sometimes the smallest objects can transform how we view entire planetary systems. Conclusion. In conclusion, Webb first detected S/2025U1 on February 2nd, 2025, in 10 long NIRCam exposures. The data suggest it is about 10 kilometers wide, assuming typical reflectivity, and orbiting roughly 56,000 kilometers from Uranus's center, between Ophelia and Bianca. This result remains provisional and awaits peer review and independent confirmation. Next steps include repeated Webb detections, Hubble photometry to refine its size, and ground-based monitoring for possible ring effects. Watch for these results, as they will decide its role. Subscribe for follow-up coverage, and share in the comments whether you think it's a Moonlet, Shepherd, or Fragment. Small objects can change our models. This tiny moon may do just that.